Hi and Assalamualaikum. We are from Group 2. My name is Nik Muhammad Darwish bin Hafizul and my amazing teammates are Muhammad Hasif bin Ismail, Ahmad Daniel bin Hanizan, and Muhammad Lutfi Hazim bin Muhammad Hilmi. We are going to present about our topic, which is related rates, where we are focusing on rate of changes.
What is differentiation? Differentiation is a fundamental concept in a calculus that involves finding the derivative of a function. The derivative measures how a function changes as its input, usually denoted as x change. Differentiation defined as dy over dx. There are a few applications for differentiation. There are related rates, apply maximum and minimum problems, analysis of a function, Rolle's theorem, and mean value theorem.
Okay, let's go to our topic. Introduction. In the definition calculus, related rate problem involve of two or more variables that change at the same time, possibly at different rate. The rate of change usually respect to time.
Here we got two objectives. The main objective is in a related rates problem. The idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. Then, the second objective. The procedure is to find an equation that relates the two quantities and then use the chain rule or implicit to differentiate both sides with respect to the time.
Okay, let's go to the problem statement. Question 1. A block of ice in the shape of cube originally having volume 1000 cm3 is melting in such a way that the length of each edge is decreasing at the rate of 2 cm per hour. At what rate is its surface area decreasing at the time its volume is 64 cm3? Assume that the block of ice maintains its cubical shape.
Let's solve the question together. First of all, let's find every information that mentioned in the question. The first information is that the initial volume for the cube, which is 1000 cm3. The second one is the rate of melting. So they are mentioned that the rate of melting for the cube is 2 cm per hour. So the rate of melting is known as in the decreasing rate. So we must add negative in the form of value. And also the rate of melting is known as dx over dt. So that was our first chain. The second one we could get from the area formula. We already know that area formula for a cube is 6x squared. Therefore, by using derivative formula, we could get the dA over dx for the area formula, which is 12x. Then we already have the dA over dx and also dx over dt. That was our perfect chain rule. From the previous slide, we already get both chain, which is dA over dx and also dx over dt. So let's find the x value. So the question asks for the rate of its surface decreasing when the volume is 64 cm3. Therefore, the final volume for a cube is 64 cm3. By using the cube formula, we could know that the cube formula for volume is x to the power of 3. Therefore, 64 equal to x to the power of 3, and we could solve for a value of x, which is x equal to 4 cm. from the previous slide, we already know the value of the A over dx, dx over dt now, and also the value for x. Therefore, everything that we need to do right now is to sub the value into the chain rule formula. But what is the question that we are?
Question 2. Water is being poured into a cone-shaped teapot at the rate of 7 cm3 per second. The cone has maximum radius of 9 cm and height at 28 cm. The question is, at what rate is the height when the height of water is 7 cm?
So the first solution is we need to collect all the information that we can spot from the question, which are radius, height, and the rate of the water being poured. After that, we need to know the cone volume formula, which is volume equal to 1 over 3 pi r square h. The radius and the height of the water are related by similar triangles, so we can conclude that r over h equal to 9 over 28. So we move the h to the right, so we can get r equal to 9 over 28 h. So we are going to replace the r into the cone formula, which is the result is going to be v equal to 23 over 784 pi h cubic. So we are going to use the derivative formula into the equation. So it's going to be dv over dh equal to 81 over 784 pi h squared. Then we are going to add the value of 7 cm from the question, which is the height of the water when it reached 7 cm into the equation. So the result is going to be dv over dh equal to 81 over 16 pi. So we are going to use the chain rule formula, and in this situation, the equation of the chain rule formula is going to be dh over dt equal to dh over dv multiplied by dt over dv. So in this case, we don't have dh over dv, so we are going to flip the equation earlier that we have dv over dh into the dh over dv. So it's going to be dh over dv equal to 16 over 81 pi, and then we are going to put into the chain rule, which is going to be 16 over 81 pi multiplied by dt over dv, which is the value is 7, and the final answer is going to be 112 over 81 pi.
So, in conclusion, we can say that differentiation is a powerful tool used in everyday life to understand and analyze changes. We can use it to compute the rate of change and accurately count the difference in change occurs. Additionally, it enhances algorithms in technology, improving apps and services. By providing insights into rates of change, differentiation helps in making informed decisions and improving the quality of life. That's all.